Hello, everyone. In this short session, we will simplify one of the most important concepts in statistics, which is hypothesis testing. By the end of this lesson, you should be able to understand what hypothesis testing means, distinguish between the null and alternative hypothesis, understand what a p-value tells us, and know when to use a t-test, chi-square test, and ANOVA test. So let's begin. Hypothesis testing is simply a method we use to determine whether an observed result is likely to be real or whether it may have happened by chance. Imagine a doctor wants to know whether a new drug lowers blood pressure better than an old drug. So if one group improves more, we ask, did the medication truly make a difference, or could this difference simply random chance by random? That's the purpose of hypothesis testing, to determine that. There are some, we use some, in hypothesis testing, we start with two competing ideas. The first is null hypothesis, written as H0. This assumes no difference exists. In our example, the new drug performs no better than the old drug. The second one is alternative hypothesis, or H1. So we have H0, no difference happens. H1, there is a difference. This assumes there is a real difference. A common mistake students make is thinking we prove the alternative hypothesis directly. No, actually, we look for enough evidence to reject the null hypothesis. So now let's talk about one of the most misunderstood ideas in statistics, which is the p-value. The p-value tells us how likely our result could happen by chance if the null hypothesis were true. Think of it like this. If the p-value is very small, usually less than 0.005, we say the result is statistically significant. That means the observed difference is unlikely to be random chance. So we reject the null hypothesis. But remember, a p-value does not tell us how important a result is clinically. Statistic significant and clinical significant are different things. Let's talk about the t-test. A t-test is used when we want to compare the average or mean of two groups. For example, does drug A reduce blood pressure more than drug B? So we compare the average blood pressure reduction between two groups. Just to simplify it for the students to memorize it, t-test and two groups, they both start with the letter T. So students often remember it using that method. Next one is chi-square test. Chi-square test, we use chi-square working with categories, not averages. For example, are smokers more likely to develop lung disease? Notice this is not a numerical average. Instead, we are comparing categories, yes or no. A useful shortcut, if the answer involves percentage, promotions, or categories, think chi-square test. Last but not least, ANOVA test. So ANOVA stands for analysis of variance. ANOVA is used when comparing the means of three or more groups. For example, suppose we compare drug A, drug B, and drug C. A t-test only compares two groups. So when there is three or more groups, we use ANOVA. We have a table here just to simplify everything for you guys, just to help to memorize it. Now let's summarize everything up here. Hypothesis testing helps us determine whether a result is likely real or due to a chance. We begin with null hypothesis and alternative hypothesis. which is H0 and H1. Then we interrupted the p-value and choose the correct statistic test, which is whether it's t-test or chi-square or ANOVA. And thank you.